Hey Advanced Algebra, welcome to day 2 of solving systems with substitution. Our EQ today is how can I use substitution to solve word problems? Yesterday we were introduced to systems of equations by understanding that in order to use substitution you had to have a variable that was isolated in order to plug that into the second system. So in this problem, for our warm-up, we have a variable that's by itself, that is y, which allows us to plug in negative 3x plus 5 into our y value. Again, substituting, simply replacing with the variable that is isolated. So if I rewrite this, it becomes 5x minus 4 times negative 3x plus 5 is equal to negative 3. Okay, so that was able to be replaced. Now I have an equation with one variable, which I'm able to solve for. The first step in doing that is to distribute. A reminder that you have to distribute that negative 4 through. So negative 4 times a negative 3x is a positive 12x. A negative 4 times a positive 5 is a negative 20. And I bring down the 5x. And this is all equal to negative 3. Now we have terms that can be combined. So I can combine my 5x and my 12x to get 17x minus 20 is equal to negative 3. I add 20 to both sides to continue to get that x by itself. 17x is equal to 17. I divide by both sides by 17, and x is equal to 17 divided by 17, which is 1. So I have my x coordinate for my solution, but as we know, a solution to a systems of equations is an x comma y point. So now I have 1. In order to get my y, I'm going to go back up to my original where it says what y is equal to, and I plug in my x. So y is equal to negative 3 times 1 plus 5. And I got that from the one that I solved for. Negative 3 times 1 is a negative 3, so negative 3 plus 5, y is equal to a positive 2. So this y then is my y coordinate of my solution. Today we're going to talk about what happens when we do not have a variable by itself on one side. So there's no variable that's isolated. If you look at the systems of equations below, we have a negative or 3x, a negative 6y, a negative 2x, and a 5y. Which means that there's no isolated variable that we can use to substitute, so we have to decide which variable can we move the equation around to get by itself. Typically, we ask ourselves, what is the smallest number? And in this example, the smallest number is negative 2. When you find the smallest number, you then have to ask yourself, is everything in that equation divisible by that number? Because eventually we'll have to divide everything. Well, I know that 22 can be divided by 2. However, 5 cannot be divided by 2 evenly, which means that this is not a number that we want to get by itself. So then let's go to the next smallest, which is 3. And if we do the divisibility test, 6 divided by 3 is 2, 27 divided by 3 is 9, which allows us to rearrange this equation to get the x by itself, because then we have an isolated variable to plug into the second equation. So let's look at this. 3x minus 6y is equal to negative 27. And we want to get this x by itself. So the first thing we're going to do is to add 6y to both sides. Those cancel, and we end up with 3x is equal to 6y minus 27. We cannot combine those because one has a y and one doesn't. And then the final step is to divide by 3. And just like with solving equations, we have to divide every term by 3. So x is equal to 2y minus 9. Now we have a variable that is by itself in order to plug into our equation to solve the systems. I personally like to rewrite it underneath. So x is equal to 2y minus 9. And cross out our starting equation so you don't get confused about which equation you should plug in to. Okay, so we rewrote that one so we won't be using that. We are able to plug this x, 2y minus 9, into the x variable of our second equation. I rewrite this, negative 2 times 2y minus 9 plus 5y is equal to 22. You'll notice a pattern. Usually the first step in solving these is going to be to distribute. So I'm going to distribute the negative 2 through. Negative 2 times 2y is negative 4y. Negative 2 times negative 9. Negative times a negative is a positive, so plus 18 plus 5y is equal to 22. Then we have terms that we can combine, so a negative 4y plus a 5y. Negative 4y plus a 5y gives us 1y. If you want to write 1y, just to remind yourself, 1y plus 18 is equal to 22. And now we have really a one step because we have that 1 in front. Let's shrink this real quick. So my y is equal to 4. Okay, again, this is my y coordinate of my solution. I know my y is 4. In order to get my x, we are able to plug this in to the equation that we rewrote because x is equal to 2y minus 9. Now we know x is equal to 2 times 4 minus 9. 2 times 4 is 8. 8 minus 9 is negative 1. The x-coordinate of our solution is negative 1. So the first step that we had to do here was find the variable to get by itself. Once you do that, you follow the same steps that we did yesterday with your newly written equation that has the variable isolated. All right, let's look at another example. So, deciding which variable to get by itself. I like to highlight so you can see all the variables. You know me in color coding. I think it's easiest to work when you can color code things. So I have 6y, a 2x, and a negative 5y. The easiest thing to do is ask yourself, what is the smallest variable, or what is the smallest coefficient attached to a variable? Here we have a 2, right? We have the 2 right here. And then asking, is everything in that equation divisible by 2? So can everything in the equation be divided by 2 and equal a whole number? Well, 6 divided by 2 is 3. 32 divided by 2 is 16. So yes, which means that we can rewrite this to get the x by itself. Rewrite it over here. solving to get this x, oops, I need that in yellow, this x by itself. I'm going to minus 6y from both, gross, don't want to write in yellow, Miss Michael. Minus 6y from both sides. And I get 2x is equal to negative 6y minus 32. If you're having difficulty with rearranging these, please let us know. We talked about in chapter 1 how critical it was for you to know how to solve equations, and this is why. Lots of equation solving when solving for systems. X is equal to negative 6 divided by 2, negative 3y. Negative 32 divided by positive 2 is negative 16. Now I have a variable that is by itself, which allows me to take this equation and plug it in to my x in the second equation. So if I plug that in, I have 2 times negative 3y minus 16 minus 5y is equal to 27. And again, that negative 3y minus 16 came from our equation that we just solved for, getting x by itself. 2 steps in this is always the first, distributing. So 2 times negative 3y is negative 6y. 2 times a negative 16 is equal to a negative 32. Minus 5y is equal to 27. I combine some terms. Negative 6 and a negative 5y. Remember, 2 negatives get more negative. So I have a negative 11y minus 32 is equal to 27. I'm going to add 32 to both sides. And I get negative 11y is equal to, where did I mess this up? You know what? This number up here was supposed to be 23 up here. This was supposed to be 23, and it's 27. Because this is going to be a decimal. But let's keep going. 7, 8, 9, and 5. So negative 11y is equal to 59. If I divide both sides by negative 11, I get a very nasty number of y's equal to 5.36 repeating. Okay, for the sake of doing this example problem, I'm going to finish it. Our numbers aren't going to be perfect, but hey, sometimes numbers aren't perfect in lessons. Promise you, you'll always have whole numbers on a test. So I know I have my y, which allows me to, I have to look back and say, okay, where was my x? And my x was here, so now I'm making a big circle and plugging my y into there. And x is equal to negative 3 times 5.36 minus 16. And if I just type this into the calculator real quick, again, it's not going to be a whole number. So I have negative 3 times 5.36 minus 16. X rough estimate is negative 32.08. Now, this is not ideal because our numbers were not accurate like they should have been. Oh, and guess what? Miss Michael made another mistake. I was trying to figure out how that number got so big. This is what happens in math, right? And this is why I don't redo videos. I just keep working. This y should have been negative, which should have made that negative. So let's go back through and see. Negative 3 times negative 5.36 minus 16. Now that makes more sense. So you can see with that error that the slightest forgetfulness of our positive and negatives can lead to the wrong answer. So even myself, a teacher, can forget my negatives. So make sure you double, triple check when you're multiplying and dividing by negatives that you have the right sign in the end. All right, why don't you pause the video, try this problem on your own, and then come back and see if you were able to do it correctly. All right, so hopefully you went through this. First thing you have to ask yourself, smallest number. The smallest number is -2. 6 can be divided by -2, and 6 can be divided by -2. So that y is, or that x, excuse me, is what we want to get by itself. -2x plus 6y is equal to a +6. Getting that x by itself, I'm going to minus 6y plus 6y, and then finally divide by -2. My x is equal to negative divided by negative. Here it is again, a 3y positive. Positive divided by negative is a -3. I like to go back and cross this out so I don't accidentally use that. Now I'm going to take my x, plug it in, and I have -7 times 3y minus 3 plus 8y is equal to -5. The first step is distributing. -7 times -3y is -21y. -7 times a -3 is a +21 plus 8y is equal to -5. I then have terms that I can combine. You can see that we're following the same pattern. Plug in, distribute, combine like terms. So -21 plus an 8y is equal to a -13y plus 21 is equal to -5. I minus 21 from both sides. And a -13y is equal to a -26. -5 minus 21. Finally, divide by -13. A -26 divided by -13, our y is equal to 2. So that's one part of my solution. Can now plug it in to my y of my solo x. So x is equal to 3 times 2 minus 3. 3 times 2 is 6. 6 minus 3 is x is equal to 3. Now I have a solution of 3, 2. All right, let's look at one word problem together. So your family's planning a week-long trip to Florida. You estimate the cost will be $275 per day in Tampa and $400 per day in Orlando. Your total budget is $2,300 for the week. How many days should you spend in each location? So the first thing I always ask myself, there we go. The first thing I always ask myself is, what are my totals? Okay, for each of these problems, you should have 2 totals. Well, I know one total is going to be the dollar amount. Okay, so one total is going to be the dollar amount. Now you have to ask yourself, what's your other total? Well, 275 days per day in Tampa, 275 is going to be connected to the dollar amount total, and so is 400. And the question is asking, how many days should you spend in each location? So there needs to be a total related to days that we didn't highlight, so let's go back and look. Your family's planning, there it is, a week-long trip to Florida. So this is my other total, the number of days that I want to be gone. So a week-long trip is 7, which becomes my second total. That is step 1. Step 2 is to define your variables. What are the two options or things that you are deciding between? This can come typically from the question, how many days should you spend in each location? Well, X then is days in Tampa. And then my Y is days in Orlando. As we said, the total is going to be 2,300. So any other dollar amount in our problem is going to go with that total amount. So days in Tampa, well, how much does it cost per day in Tampa? $275. Per, we know, is multiply. So times X plus how many days, how much does it cost to spend one day in Orlando? $400 per day, so multiply by days in Orlando. Now my second one, I will tell you that 95% of the time, the second one is simply going to be adding my X and my Y together, which for this one makes sense. How many days should you spend? Well, if you're going for a total of 7 days, X is the number of days that you're spending in Tampa, and Y is the number of days you're spending in Orlando. So by adding those together will give you your total of 7 days. If we're solving by substitution, you ask yourself, is there any variable that's by itself? No. However, there's no coefficient or no number in front of the bottom X and the bottom Y, so you can get one of those by themselves. So if I rewrite this, X plus Y is equal to 7. Let's just get X by itself because it's first, does not matter. Minus Y from both sides. X is equal to 7 minus Y. Now you can take 7 minus Y, lots of colors for this one, I guess, and plug it into your equation. 275 times 7 minus Y plus 400Y is equal to $2,300. And just like with everything we've been doing, we're following the same steps. First thing is to distribute. 275 times 7 is 1,925 minus 275y, because you're multiplying those two, plus 400y is equal to 2,300. Second step is to combine like terms. Watch your negatives here. So I have negative 275 plus 400, which is 125. So 1,925 plus 125y is equal to 2,300. I'm going to subtract 1925 from both sides. And I'm definitely running out of room on this screen. I'm trying to shrink this without like totally messing everything up. 125y is equal to 2,300 minus 19,000. Nope, wrong number. 1,925, which is equal to 375. Finally, I divide both sides by 125. And that gives me 3. Now with word problems, the biggest thing is to ask yourselves, what does that 3 represent? So you go back up and see that, well, my Y value stood for days spent in Orlando, which means that if I want to be in Orlando for 7 days, or if I want to be in Florida for 7 days, I'm just going to erase that line because it's messing everything up. but I only want to spend 2,300. I'm going to have 3 days in Orlando. And how many days do I have in Tampa? Well, 7 minus 3 is 4. So 4 days in Tampa. Your word problem should always give an explanation for the solution, okay? All right, this next word problem we are going to go through together in class. So try to do this on your own, and then we'll go back through it during class. And then your homework is 3.22, solving systems by substitution.